Continue the project. Or take the.
Yeah, what is the project?
What if we do slideshow of everything we've learned?
I would do.
Look,
It was
What if you file your taxes? Just like do-
well, first of all, deadline's not until October now.
But you wanna
Yeah,
do
because
it
California disaster. But I have an account that does it. I have an account that does it, and I'd rather have an account do it. I don't want to get audited, so. I no, not as good. Well, let me get back to you on that. So I still haven't thought that far ahead. So. Okay, anyway, so let's talk about polynomial functions and quadratic functions. So a polynomial function, really simple. It's just a function. I'll use a text box. Oh, here we go. So just a function with multiple terms in the form of a times x raised to the n power. I know it looks a little tricky how I just typed it up. But it's just a function with multiple terms in the form. So what I mean by that is like this. So a good example would be this, right? Y equals, say, I don't know, 2x cubed plus x minus 5. That's a polynomial function, right? Because do you have multiple terms? Yes. Are they in the form of x raised to the power? Yes. Right? So that's a polynomial function. That's what we're working on today, but more specifically, we're doing quadratic functions. Something that would not be a function, so not a polynomial. What's like y equals 2 over x squared minus root x? And actually, let me rephrase. Let me add a little wrinkle to this. N is a whole number. That was a very important detail I left out. N's a whole number. So we have 2 over x squared. What will be the exponent here, by the way? 1. Or 2. No, 2 over x squared. You have x squared on the bottom. What's the exponent? You have to know this. Is it positive or negative the exponent?
Which one?
2 over x squared? Yeah, what is it exactly?
Hi.
No, nothing imaginary numbers. You guys remember this, right? When you have negative exponents, where does it go? The bottom. What's the exponent for this one? We have radical. Square root. 1/2. Thank you, Claire. Are those whole numbers? Is negative 2 and 1/2 whole numbers? No. So that's not a polynomial function because the exponents are not whole numbers. But here, the exponents are 3, 1, and then there is an x here. It's kind of an invisible x. Just raise it to 0 power. That's a whole number also. So those are polynomial functions. More specifically, and we're going to talk about polynomials in more detail later in the scene. More specifically, we're going to talk about quadratic functions. And the standard form is this. Ax squared plus bx plus c. You guys should know this, right? So pretty straightforward, right? Shouldn't be too complicated. Let's move on to the middle of the page here. Let me just shift this up. There we go. All right. So y equals x squared. The graph is very simple. Let's make a table really quickly. Let me plug in some numbers. 2 and negative 2. Okay, what if I plug in 0? What do I get? 0. What if I plug in 1? And this equation here, by the way, guys.
1.
1. How about negative 1?
4.
How about 2?
4.
Negative 2.
4.
Plot the points. And you guys know how the graph looks. Just gotta squint a little bit here. All right, and then let's just plot this guy. Yeah, I know, it's terribly exciting stuff.
Sorry.
Okay, no worries. No, I know. I'm just give me a just exactly that's what I'm doing. Okay, domain we know is all real numbers. Range is this. X-intercepts is 0, 0. It's also the y-intercept. It's decreasing from negative infinity to 0. Increasing from 0 to infinity. is an even function. Axis symmetry is x equals 0. And the vertex is a min. So I know I went to that rapid fire, but hopefully, but as you're done copying, we'll just simmer on this for a little bit. Again, y equals x squared. That's the most basic probably you can ever think of, right? There's no vertical shift, there's no horizontal shift, there's no reflections, no stretches. Just a very plain vanilla quadratic number. Y equals x squared. Domains always be all real, regardless if I shift it. The range could change if I shift it up or down, or flip it over, but I didn't. Goes from 0 to infinity. The intercepts work across the x-axis or the y-axis, both of the origin. Decreasing is dropping. So as as we move from left to right, the graph is dropping, right? And then also it's a low point that starts rising. It's kind of like a roller coaster. You dip down, and you can come back up. Come back up again from 0 to infinity. Even function, remember symmetry of the y-axis. Also becoming positive is the -1, get the same outputs. And then lastly, x symmetry is x equals 0, and then vertex, the low point. So that should be like the anatomy of a quadratic function. Of course, things could change a little bit if I transform the graph or the function. Vertex form, you guys should know this also. Y equals, for those who have, I already asked this, anyone taking ACT this Saturday? Yeah, you kind of need to know a lot of this stuff here. So it should help for the ACT for doing that this Saturday. And seniors are probably just laughing away like they don't have to worry about that anymore. So
Facts.
exactly. So y equals x minus h squared plus k.
See what
H comma k is the vertex. Okay, so we're okay with that? Okay. So let's do an example. We got several examples to go through, but we'll get through them. And then you guys can do the homework after that. And hopefully I have no homework for tonight. Example 1. You're asked to sketch the graph, find the vertex, find the axis of symmetry, find the x-intercept, find the y-intercept. Okay, you can go about this several ways. It's my job to help you be efficient. And just to be honest, I'm gonna get my soapbox a little bit, just to, kind of put a little disclaimer out there. You're never really going to use this stuff. I mean, like for the seniors, I mean, you're going to be studying other stuff. You're not going to really be using this stuff. But the whole point of doing these kind of problems is help you find efficient pathways, right? Like maybe you'll be a coder, maybe you'll be a salesperson, maybe you'll be something else. But you got to find efficient pathways, right? I don't want you doing this problem in a very laborious way. I want you guys finding a way that's efficient. That's why we do these problems. Because I know you're not going to do factoring or graphing problems in real life. I want you to be efficient though. So what ideas do you guys have? How can I go about graphing this and find those things? You factored. Thank you. That I would agree with what JP said. Yes. You could make a table. I don't think it's a good idea because then you're randomly picking numbers. You could, there's a formula you can use to find the vertex. You might remember this formula, x equals negative b over 2a. You might remember that. You could do that to find the x coordinate of the vertex, to find the y coordinate of the vertex. I don't know if I would do that either. If you really want to get fancy, you could do completing the square. Again, vertex form. I don't know if I would do that either. If you can factor, I would do that. So factoring, I would suggest. Factoring is recommended if you can factor, if possible. Now, JP, how do you factor it?
Well, I factored it to -2x to 6x.
Right.
X equals -6x.
So you should, well, hold on. You got x minus 6. So x plus 6, x minus 2?
Yeah.
I agree. Good. So that's what f of x equals. So what this means is that your x-intercepts are -6 and 2. Good. So hold on. I think I went too far. 1, 2, 3, 4, 5, 6. I don't like this grid. It's just really hard to read.
Small.
And 2.
Actually, pretty average.
Okay. What do you guys think the axis symmetry is? If you know where the midpoint. What's the midpoint of these 2 points, guys? Negative. -2.
Oh, wait, that was first.
Oh, sorry, I didn't hear that.
It's okay. Anytime.
All right. So it's gonna go right through the middle, as it should, because that's how these are designed. So it means the vertex is -2 comma something.
It's negative.
You plug the back in?
Mhm.
Good, thank you. Yes, if you do f of -2, I like that. Thank you, Iris. You get -2 plus 6 times -2 minus 2, which is 4 times -4.
Wait,
Which is-
sorry. Never mind. Can I-
-16, right? Or am I wrong?
No.
Okay,
Doesn't fit.
doesn't fit, which is kind of whatever. I'll just put it down. I'll just say it's -16 down here. Just use your imagination. All right, and then the y-intercept, just plug in 0.
For that X function.
Yep, you get -12.
Wait, so can I always plug in 0? or,
Yep.
Like my X value, so 0 plus 6.
Yep. You do in the factor form, you get -12 still. Yeah.
Wait, I. So you're between-
I went halfway between -6 and 2. Because -6 and 2 is 8 apart, right? The distance between the x-intercepts is 8 apart. And half of 8 is 4. So you gotta go 4 in each direction from the x-intercepts. So that's how you find it. Yeah, this is the most efficient way for doing the problem. It's not formulaic, it's more understanding and using a skill set like factoring, right? So, okay, let's keep moving. Now in this case, it's already given to you in vertex form, right? So again, let's write this out. Vertex, axis symmetry, x-intercept, y-intercept. Okay, vertex is actually already there. What's the vertex going to be?
8.
Negative.
3.
We say positive 3. Because remember the formula is this: y equals a x minus h squared plus k.
So throw the outside numbers and then.
Yep. It's all about shifting. So 3, 8, 2, 4, 6. I think I'm in the right place. We'll just go with that. Axis symmetry is x equals 3.
How do we know that?
It's always the x coordinate of the vertex. The vertex right in the middle. And symmetry is about middle. X intercepts, it's gonna be a little tricky. I'll do it off to the side here. So let's change colors, go to light blue. So 0 equals -2 x minus 3 squared plus 8. Remember, when you're on the x-axis, what does it mean to intersect the end way, right? When you're on the x-axis, let's treat about y. Y is always 0. That's where I place y to 0. Solve. How would I solve this? What the equation I wrote in blue? What would I first do?
Move the 8 over.
Move the 8 over.
5 by -2.
And divide. Yeah, don't distribute it or FOIL. I would just do that.
Where's the left side?
Square root both sides.
Yeah.
You square root plus or minus 2. So is x equal? So you should get 5 and -1.
How did you get -1?
3. Oh, sorry, +1. Sorry. No, you're right. I was wrong.
I still don't know.
Oh, okay. I thought you questioned me, but you should. 3 plus 3 minus 3 over. You get 3 plus 2 and 3 minus 2.
Okay.
Remember, we solve by square root and got plus or minus. And now I can draw the parabola. I have enough information. As long as you have the vertex and 2 of the points. Yikes, what did I just do? As long as you have the vertex and 2 of the points, you have enough to graph. And then the y-intercept just 8. Just plug in 0 for x. Wait,
It is -1.
wait, whoa, hold on, I'm wrong. The y-intercept's not 8. No, 3 plus or minus 2. 3 plus 2 and 3 minus 2. Right, 5 and 1. My bad for the y-intercept. I got to plug in 0. I jumped. I jumped the gun there on that one. -2 times 9 plus 8. Should be -10. I clearly didn't do that to scale, but whatever, it's fine. Okay, so we're good with that stuff. So standard form is example 1, and fortunately it was factorable, so we factored it and we got the x-intercepts and graphed it. Example 2 was in standard form, sorry, vertex form. So I identified the vertex from the equation, plotted it, found the x-intercepts by doing a little solving off to the right of blue. Once I got the x-intercepts, I can graph, and then y-intercept is plug 0 for x. And axisymmetry is always going to be x equals the x coordinate of the vertex. Okay, so it should be all review stuff you should be very comfortable with. Let's keep on trucking here. Okay, so here they're asking you to find the max or min value. That's just the vertex, just so you know. And this opens. How's this going to open, by the way, up or down? Given that you see it, you have a -2x squared. What do you guys think? Down. Thank you, Claire. Opens down. So then the vertex will be a max in this case. All right. In this case, I don't know if I would factor it. It might be a little hard to factor. Actually, we could factor it.
Good.
You could. Or you could do this. Negative b over 2a. Because I'm just being asked to find a vertex, not graph it, I think I'm okay doing it this way. But do you know where this formula comes from? Zero now? More. Remember quadratic formula? Yeah, the radical part. The radical part goes away because you're finding the average of the x-intercepts. So if you were to average the quad form, the radical stuff would go away. That's where it comes from. So I would have -40 over 2 times -2, so that's 10. Plug in 10 into your equation. You should get 9 plus 400 minus 200. So you should get 209. So your vertex is 10, 209.
Damn, that's a big ass number.
It totally is. But that's that's probably the most efficient way I would say using that formula, negative b over 2a. And again, negative b over 2a comes from yeah, sometimes students just memorize this formula and they really understand why. And kind of like we get going for that, but negative b plus or minus square root of b squared minus 4c over 2a. If you think about it, what does that represent when you do plot form? What does that represent on the graph? What key feature would these two answers represent on the graph? What? The x-intercepts, yes. These are x-intercepts. Because y equals 0. Why even this in the first place? D equation equals 0 to solve for x. So, for example, this would be negative b plus b squared minus 4ac all over 2a. This would be negative b minus b squared minus 4c. You guys don't have to write this down, but now remember we had this earlier? We had 2 and -6. What's the average of these two numbers? What if you average these two? What would you get? -2, good. What if you average these two? If you were to average these two out, what happens to the radicals when you add these two together? What happens to the radicals, guys?
Cancel out.
They cancel out, good. So you want to get negative 2b over 2a all over 2. Those twos cancel to get back to negative b over 2. That's where it comes from. In case you're curious. Because the vertex is going to be the average of those x-intercepts. So it's not something that fell out of the sky. There's a rhyme and reason to it. And how do you get quad form? That's another derivation, which I won't get into, but involves completing the square. But I won't get into that. Okay. Example 5. I had students in Algebra 2 really struggle with these problems when I taught Algebra 2. Well, I still teach Algebra 2. But in the past, I had students really struggle with this because they really were incredibly inefficient. What does the question want? what's the question asking for? An equation, right? In what form? And we know vertex forms this, right? Well, do you have the vertex? Yeah. Let's plug it in. What's vertex? So what I'm gonna plug in for H, guys. X. That's not the vertex. 3. That's a random point, the 1, 2. What's the K value though? Thank you, Natalia. But am I out of the woods yet? What do I still need to figure out? How do I get A? Good. Excellent. 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 Yeah, that's the part sometimes people like, they just kind of stare at the problem like, well, I gave you that information for a reason. You have to use it, right? And you solve for A, which I know you guys can do. God bless you. So 2 equals 4A minus 4. 6 equals 4A. A is 3/2, right? So the equation is y equals 3/2 x minus 3 squared minus 4. So again, stuff you guys have already done. Shouldn't be too hard. Okay, with the home stretch here. Example 6. You have 2 x-intercepts. You're asked to find 2 different quadratic functions, and you're told there are many answers. One has to go up, one has to go down. So you could do this if you want. F of x equals a x minus 4 x plus 8. And you can make a whatever you want. Like I could do this. Those look having fun. A could be anything. So you could say y equals 2. Or you could say y equals like -2. I just chose 2 and -2. It could be really anything. Is everything okay out there?
Yeah, everything's fine.
Good, all right. So anyway, that's just pretty straightforward. I didn't ask you to put it in a particular form. You didn't have to put it in standard form or anything like that. So, yeah.
Those are guys.
No, that was Everyone's going crazy. I don't know why. Those are in the back.
What class were they out in the hallway?
I don't even know. I thought it was computer science.
Okay. Okay. But anyway, the problem like this is very open-ended. I probably won't ask this on a test because I'd like to have one answer. But you have the x-intercept, so you could write intercept form or factored form. So, so that's another thing too. Easy to express in intercept form. Okay. And last up, just a word problem. And we're done. And homework will follow. So SHP Little League is a baseball throwing machine that helps train 10-year-old players to catch high pop-ups. It throws baseball up with an initial velocity of 48 feet and height of 3.5. Just a little bit of physics involved here. Let me look at the homework, see if that's a problem I care about. We could just cross it off. Yeah, just cross off the last example. That's totally fine. Okay. So we're done with the notes for today.